Good morning, everyone. It's Thursday, May 7th. Here's beer still getting longer, thinking about cutting it. But today I just wanted to give a brief introduction into geometric sequences, crazy sequences. But wanted to make sure I said hello before, make sure you're okay, safe and sound. Fill out the check-in form and then get to the math task. Enjoy. Let's get started. All right, before we begin the math, here's something to consider when you're thinking about geometric sequences. This is just based on a recent screenshot of data or a scenario if a person comes in into work with an infection of COVID-19. Something you should look into is that everything begins at zero. It's called ground zero for a reason. Geometric sequences are really, really weird because they start off growing really, really slow, and then they start picking up momentum, and then it's just a spike. Another word to think about is exponential growth. So as we go through this math today, this is the type of growth we're looking at. So it's going to look different, but I think you'll have a solid understanding before you leave this task. All right, here's the task of the day, our geometric sequences. They all begin with the first term. It's at the beginning of the sequence. In this case, it's -2. From there, they start growing. The growth here is based on a common ratio, they call it. Ratio because it's multiplying, it's not adding or subtracting. So I noticed that this is growing by multiplying by -2. So that means that the next two terms have to be found by multiplying 16 by -2, which is -32. And then the -32 times -2 will be 64. So those are the next two terms of the sequence. So your job is to do that with all the other sequences. Find the next two. The first term, it was pretty obvious. It was at the beginning of the sequence and it was -2. And the common ratio, I looked at the pattern and I figured out what they were going by, and I noticed that they were multiplying by -2. Now we're going to use those two to make up an explicit function. It's an equation, so don't panic. The first thing that goes into an equation is the first term. The first term was -2. Okay, since these are not arithmetic sequences, these are geometric, you're going to multiply with the common ratio. And because the growth is so high, the variable has to be an exponent. So whatever the arrangement, the term number you want to use, that's what n represents. Any of those, 1, 2, 3, 4, 5. But we still have to go back to the beginning. Remember 0 from the graph? We have to go back 1 always, so we can get the accurate measure of any of these terms. And then -1 takes you back to 0 because everything begins at 0. So we're going to calculate the 10th one. Same pattern. You have to use the same values. It's 2, the first term, times -2 to the nth power. Nth power means 10 because we're calculating the 10th one. That means if this keeps on going to the 10th one, subtract 1, what will be the value? Then you can go ahead and simplify it a little bit, just a little bit, so we can multiply the values. So -2 times -2 to the 10 minus 1. So 10 minus 1 is used to the 9th power. So that's what we're going to type in, -2 times -2 to the 9th power in the calculator. So here's the calculator in Google Classroom. I suggest you use that one. It's the easiest one to use. And then you just go from -2 times -2. And you want to put that in parentheses because then it will give you the correct values. To the is the A-B button. I press the A to the B button, and then that's to the 9th power. So it will give you the actual value of that word. 10th term is worth 1,029. That's what that equal to. So notice the numbers are humongous. This is the growth for geometric sequences. It's humongous. The other type is when it's decreasing at a fast rate. The first term is 100. Then it's went down to 20. So 100 divided by something is 20. 100 divided by 5 is 20. Yep, so the constant ratio is 1/5, or is dividing by 5. You can type it in as 1/5, 1/5, or you can also divide it by 5. So let's create our explicit function. I don't like saying divided by 5 because it really doesn't make sense, but divided by 5 is the same as 1/5. So the explicit formula is going to look like this. It's going to be 10 times, because that's the first term. Remember, that always goes at the beginning. The common ratio is 1/5, and we always want to go back to 0, so we're going to use n minus 1. Now we can substitute this into a calculator to calculate the 10th term. So write it out so you know what you're typing in. 10 times the common ratio, which is 1/5. The number we're trying to calculate is the 10th one, but we're going to subtract 1. So in reality, we're just going to type in 9 into the calculator. Okay? Well, picture this, and let's put it in a calculator, see what it does. 10 times 1 Kardashian 5 to the, you can press 8 to the 9th power. Once you type it in, it will give you a scientific notation format. This is what I would like for you to type into the Notability. And if you can, turn it into a decimal. So let's go ahead and write that down and go from there. 5.12 times 10 to the negative 6, which means it's a super long decimal. I'll write it in here. 1, 2, 3, 4, 5, 6, 112. That's the actual value of a dividing geometric sequence. So there's 2 that I've done. Pick 4 out of the ones that are left. And enjoy the task. If you need help, 1 to 2:30 Zoom hours every day, except for Mondays when it's our class meeting. So check Google Classroom for your class meeting on Monday. No excuses. Be there. See you.